okay. So like Uncle Michael mentioned, my name is Michael as well. And I'm going to be, for the next hour, we're going to be talking a little bit about grade 9 math. I currently run a tutoring center over in Markham. But again, depending on where you live, it's not super relevant. But I hope you guys enjoy this class and you take away a little bit from it. I know some of you from the last trial class I did, so I recognize Stephen and Lydia. Some of the kids here, some of the new students like Daniel and Sophia, from what I saw, you seem a little bit on the younger side. May I just ask, you guys could just type it in chat if you're too shy to say how old you are, or if you're too shy to unmute your microphone, but how many people here are actually in grade 9? Like, is it 0? Because if it's 0, then we might have to, Daniel's my younger brother in grade 5, grade 6. Okay, so a lot of this, what we're going to be talking about, may be a little bit new then. So what happens is I might have to review a little bit of linear equations with you guys first before we can do some of the practice problems. Okay, so.
Excuse me, Michael. I just checked that.
This
Hello,
person
Michael?
knows it. Yeah, hi.
Yeah. And I just quickly checked the registration for today's class. Chen has at least 2. And majority of them, they are grade 7 and 8.
Yeah, and that's okay.
8, Fairwinds is 7, but like Lydia is grade 8, right?
Lydia's grade 8, yeah, she's grade 8. Yeah. But this person in grade 6 knows it.
Sophia is a grade 7 or 8, Sophia?
No, I'm in grade 8 too.
Grade 2, yeah. Michael, actually, their parents, some talk to me privately. They're okay because some of them, even they are grade 7, 8, but they're pretty strong.
Oh, I have no problems with that. It's just they're joining in the middle. So I just want to make sure they at least know the basic equation.
Sure.
They
Go ahead.
They will know it for sure. Jerry, how did you learn this equation in grade 6? You attend extra math classes then, right? You probably do like Spirit of Math or Olympiad or something, right?
No, I do it from a math website.
So you're already on grade 9 math from math website?
Yeah.
Oh, wow, very impressive. Okay, so I'm going to operate under the assumption that most people kind of have at least done linear sequencing before. And again, let's hope I get the numbers correct this time. But back in the grade 8 level, most of you will have done some kind of sequencing. For example, 5, 9, 13, and 17. And most of you will probably realize that this is a +4 sequence, right? So it's adding 4 each time. And because the first difference is constant, in other words, it's the same value, we say that this is a linear sequence, okay? At the elementary level, you would have to write the general term for this. And again, I'm not going to go over the exact rules to writing the general term, but I like to figure out the term 0 because it applies most to what we're going to be learning today, which is putting it in the form of y equals to mx plus b. Okay, so again, the general term that you use to write at the elementary level for this is you're going to write something like 4n plus 1. And this formula will tell you the value for all of the term numbers. What you're learning in grade 9 is actually the exact same thing, with the exception that instead of writing n, you write x. So you write 4x plus 1 instead. And what happens is, instead of the value, you denote it by saying y. Okay, so your y-axis indicates the value of the sequence. And then your x represents the term number, essentially. Okay. This is going to be one of the more important concepts that you'll learn in grade 9 math. And then what happens is, instead of calling it the pattern rule in grade 9, so for example, right now you see this is a +4 sequence each time, right? They won't call it a +4 sequence at the high school level. So suppose we have y equals to 4x plus 1 as our formula. Does anybody know what they call this term? The y equals mx plus b term. What does m represent? Does anybody know? Jeff probably knows because he said that he does it. Oh, Sophia knows. Okay, Sophia, what does it represent?
Slope.
Slope, oh my God.
Slope.
Do you do extra math too?
No, I'm in the grade 9 math at school, so
Oh, holy cow. Okay. Well, you guys probably just finished this chapter because most of my other grade 9s have finished learning about linear equations already, and they moved on into, they stopped off at graphing just before the Christmas break. So hopefully that's where you are as well. So again, this will be a little bit more of a review for you then, Sophia. And we'll try and do some word problems involving linear equations so that you're not completely bored. And why is it important for us to be able to use linear equations to solve for problems then? Okay.
we didn't really do linear equations yet. We did slope, but not really linear equations. So
That's okay. You need to have the slope in order to figure out the linear equation, right? So you're definitely on the right track already. And can you tell me what B is then?
the Y-intercept.
Y-intercept, very good. Again, sometimes people might call this the initial value. But Y-intercept is the more proper term. And this occurs when x equals to 0, right? That's why when I recommend students to find the equation in grade 8 level, is to find the term 0. If you find term 0, it will always tell you the b value, right? And that gives you the y-intercept. So when x equals to 0, okay? So the y-intercept is over here, where the line crosses the y-axis. So this is the y-intercept. And the slope can be calculated by taking measurements over here, okay? Or over here, it doesn't matter. We can do the calculation for the slope. So let's use this particular example and just teach everyone, for those of us who aren't in grade 9 math, let's learn a little bit about how to calculate the slope. In other words, how to figure out the pattern rule. We know that from the previous experience that the +4 is the pattern rule, and that actually is the slope as well. A variable. I think I missed that. I must have missed that chat. I think I apologize to you, Sherry. Did you have a question for a variable? I think you were the one who answered all the variables, right? Didn't I just ask you what it was? But if we take a look at this point, we can effectively call this point 0 and 0.5, right? If we were to use this as a Cartesian plane, the x coordinate is 0 and the y coordinate is 0.5. Similarly for this one, we could say this is 1 and 0.75 if we wanted to, right? So now that we have these coordinates, we can actually calculate the slope. So the slope is always defined as delta y over delta x. The delta simply means difference. So it means y2 minus y1 all over x2 minus x1. Okay, so this is kind of a math terminology where this little triangle, the delta sign, represents subtraction. Okay, so what happens is we have, I sent you that when you're asking a question. I think you got my question late. I'm so sorry. So y2 minus y1, we have 0.75, take away 0.50, all over 1 take away 0. So we know that this slope is 0.25 over 1, which is just 0.25. Okay. So again, the slope simply tells us kind of like how steep the line is, if you wanted to think about it that way. Okay. So if we have a line that's like this, we can say that this line has a steepness of 0.25. So it's not super steep. Okay. But how we would be able to double check it is you could see that it goes up by 0.25 units for every 1 unit that it goes across, right? Goes up by 0.25 for every 1 unit that it goes across. So that's kind of the pattern rule, right? So our first unit starts at 0.5, and then afterwards our next unit is 0.75. Our next unit is 1, then 1.25. We could have written this pattern out in the grade 8 level this way, right? The term number 1 is 0.75. Oops, sorry. Term 1 should be 0.75, okay? And so on and so forth. So this would have been a plus 0.25 pattern. And you'll notice that it's the same thing as the slope, okay? So really the slope is kind of telling us what is the pattern rule, if you wanted to relate it back to grade 8 math, okay? So this tells us the slope. So the number in front of the x or the n always denotes the slope. And then the b, the last term value, tells us the y-intercept or the initial value. So hopefully that kind of makes sense and you're able to connect it back to the grade 8 math that you learned. And hopefully you'll be able to use this equation in order to solve for the general term for any potential sequences that you might occur, that you might come across in grade 8. Okay, so remember, it's always in the form of y equals mx plus b. Okay, this is known as the equation of a line. Okay, y equals mx plus b. So it could be something like y equals to 3x plus 2. It doesn't matter. These are all lines. Okay, anytime the x is to degree 1 and the y is to a degree 1, it's a straight line. It's guaranteed to be a straight line. Okay, it doesn't matter how they write it. It'll be a straight line. But we're not going to get into that right now. You'll learn about standard form eventually once you get into school. So that's not too important. Let's take a look at this particular question first. Okay, a company rents hoverboards and electric scooters. The relationship between cost and time for each rental is linear. So it's very important that they state this. Okay, so we know that it's a linear relationship. For a hoverboard, the relationship is represented in the table. So it's over here. Electric scooter, they gave it to you in the graph. Okay, Henry has $5 to spend. Which one should he rent in order to get the most amount of time? Can anybody tell me the answer? I'll give you guys a few minutes in order to work this out. I'm going to work it out over here as well. And then we'll compare answers to see if we get the same thing. Okay. Maybe $1.60. Well, we know he has $5, remember. So he has $5 to spend. So $1.60 buys you 4 minutes on the hoverboard, right? $1.60 buys you 4 minutes on the hoverboard. Similarly, you know that 4 minutes on the hoverboard, on the electric scooter, only costs you $1.50. So looking at it from a logical perspective, most likely one of these is going to be a little bit better than the other. But which one is the best? If you have $5 to spend, which one should we rent to get the most possible amount of time? So we want to maximize the time, okay? So everyone can do this a little bit differently. You can even just continue listing this table if you wanted to, okay? If for those of you who maybe aren't too familiar with grade 9 math, you can still solve this problem without using the equation, right? All you have to do is continue this table. Well, I know at 6 minutes, it's going to cost $1.90. At 8 minutes, it's going to cost $2.20. And you can keep listing it until we get to around $5, right? So it's definitely possible for us to solve this even without using very complicated math. So at 10 minutes, it costs $2.50. 12 minutes, it costs $2.80. 14 minutes, it costs $3.10. 16 minutes, it costs $3.40. 18 minutes, it costs $3.70. I'm getting a little tired. 20 minutes, it costs $4. 22 minutes, $4.30. 24 minutes, $4.60. 26 minutes, $4.90. So it's pretty close, okay? So we know that for the hoverboard rental, we're gonna get around 26 minutes if we spend around $5. So it's pretty nice. For $5, you're gonna be able to rent this hoverboard for approximately 26 minutes, okay? So how much minutes would we get for the electric scooter rental? And again, you can see that if we always list the table out this way, it gets a little tiring. Right? What if this guy had $500 to spend? We're going to be writing this table for a while. That's why it's nice for us to be able to solve these questions using algebra instead. So has anybody already solved it to tell me which one is better? Which one can I get more value out of? Lydia, I think you had your hand up, right? No? Oh, okay. So first step that I would do is I would first write out the equation. In other words, find the general term for the sequence, okay? I don't know if you guys got these equations, but hopefully you guys were able to work out these same equations. Yeah, Lydia?
The hoverboard one is better.
The hoverboard is better? Okay.
Yeah.
And may I ask how you solved your answer?
So you did your explanation of like how many minutes there are for a hoverboard, and there are 26, I think.
Okay. Yeah.
And then for electric scooter, you get 18 minutes.
You get
Basically, what I did was, so you have $5.
Uh-huh.
So you just subtract 0.5. So you get $4.5.
$4.50.
And then you divide that by 0.25.
Okay.
And then you get the amount of minutes you would get for the
Yeah, very
electric scooter.
clever. So what you just explained is actually exactly this equation right over here, right? So for example, if we have $5, we want to know how far we can get with $5, right? We would have 0.25x plus 0.5. Because this is the equation of our line. Remember, the 0.5 represents the y-intercept, and the 0.25 is the slope that we previously calculated. So what Lydia just explained is actually the exact same thing, except just in word form. Because now we have 5, take away 0.5 is equal to 0.25x. 4.5 must therefore equal to 0.25x. X must be equal to 4.5 divided by 0.25, right? And that gives me 1, 2, 3, 4, 5, 6, 18, right? So therefore, this says that for $5, you can get 18 minutes on the electric scooter. Now let's try for the hoverboard. Well, for $5 here, this is only going up by 0.15, right? Plus 1. So this would be 4 is equal to 0.15x. X is equal to 4 divided by 0.15. And I'm not 100% sure what this answer is off the top of my head. 30, no, not 30, 22. Either way, it's going to be more than 18. It's going to be like something like 26, right? So going through the math, we can see that X gives me around 26 for the hoverboard. Whereas for the electric scooter, we would only get around 18 minutes. So we would conclude that this person should be renting a hoverboard if he has $5 to spend. Okay. That being said, if he has less money to spend, then maybe renting the electric scooter is better. Okay. For example, if he only had $1 to spend, well, if you only have $1 to spend, you can actually rent the electric scooter for 2 minutes, right? It's not that bad. But if you only have $1 to spend for the hoverboard, you would actually only be able to rent it for 1 minute. So you could see that there's kind of a long-term benefit to renting the electric scooter. And the more money you have, the more likely you should probably be renting the hoverboard. Okay. The electric scooter is just cheaper in the beginning because the starting cost is just 50 cents. The hoverboard, the starting cost is already $1. At time 0, it's $1, right? So it's almost like saying you have to pay them $1 just to use the hoverboard regardless of what happens. Whereas the electric scooter, it says we just start at 50 cents, but it goes up more, right? It goes up by 0.25 cents. This one only goes up by 0.15. So that's why there's more of a long-term benefit to renting the hoverboard, okay? Hopefully, a very good job. Hopefully everybody understands that problem. So let's take a look at this problem, okay? Rin is planning a birthday party for his 10-year-old son. He's planning to rent out a gymnasium and set up stations for children to play various games. The relationship between the total cost to rent the facility and the number of children that attend is linear. Rin has written down some information about 2 rental options. It's $150 if 10 kids attend, or $270 if 18 kids attend. And then there is a school gym rental, which is based off the number of children, 5 for 100 or 12 for 135. Okay. If 16 kids are going to be attending this party, which one is better? Well, they're asking what's the difference in cost, but really we just need to figure out which one's better, right? For school purposes, you have to tell me what the difference in cost is. But which one is cheaper, so to speak? So for this one, try to give me the equation of this one and equation of this one, okay? So try to figure out what is the linear equation. Remember, it has to be in the form of y equals mx plus b. because we want to learn how to solve these problems algebraically. Lydia did it with very strong common sense. So that was very good. But at the grade 9 level, we want to start being able to write the equations with variables as an algebraic expression and solve for it that way. So which one is better? So once you guys are ready, who can tell me the first equation for the community center rental? Oh, yeah, Lydia, can you tell me the equation?
The first one is $15 per person.
It's $15 per person, but I want the equation.
Oh.
So you're saying it's $15 per person. I think it's correct, yes. But I want this equation. How would you write $15 per person as an equation? Like suppose I said, well, what if I wanted 100 kids? How much would that cost? And are you sure this is $15 per children? Let me see. What's 18 times 15? I didn't even check that. That's 4, that's 9, that's 1H, 2, 7. Okay, so you're correct. This one is $15 per person. So if it's $15 per person, the equation is really easy, right? It's just y equals to 15x, where x is the number of children that attend. So our cost is going to be 15 times x. Does that make sense? So our equation is really easy for the first one. It's just y equals 15x. There is no initial value. Initial value is 0. So community center rental is saying that even if there's no kids, you just pay 0. So if you're renting the gym and there's no kids that show up, you don't pay anything. Okay, so it's a very nice community center. There's no down deposit. There's no down payment. What about this one? Who can tell me the equation for this one? School gym rental. What's my equation of the line for the school gym rental? Yep, Lydia.
Is it 5x plus 75? Y equals 5x plus 75.
Y equals to 5x plus 75. It seems to work. Yeah, it seems to be correct. 60 plus, yep, very good job. So now that we have the two equation of the line, all we have to do now, if we know that 16 kids are going to be attending, we just have to plug in 16 here and we can figure out the answer, right? So again, 15 times 16, 0, 9, 1, 5. So the first one's going to cost us 240. And the second one, 16 times 5, that's 90 plus 75. That one's 165, right? Am I calculating this correct? That seems so much lower. 5 times 16, 30, 80, 80 plus 75. 80 plus 75, 155? Did I do this calculation wrong? Okay, I think this is correct. Yeah, I think this is correct. I don't think I'm making any mistakes in my mental math, right? 0, 9, 1, 5, 240. Okay, it's just there's such a big cost difference. I didn't really think this is correct. But obviously the school gym rental is much cheaper then, right? It's cheaper by a whole like $85 here, right? Why is the Y-intercept 75 from Brian? From over here, right? This one? Okay. So Brian asked, why is the Y-intercept 75? So that's a very good question. So what Lydia first did was she figured out what the pattern rule is in between these two. And again, you could figure that out using common sense, or you can just calculate the slope. So again, we have slope is equal to delta y over delta x, which is equal to 135 minus 100 all over 12 take away 5. So that gives me 35 over 7. So we know the slope is 5, right? It's going up by $5 for every single children. So that's correct. Okay, now that we know it goes up by $5 each time, we can figure out the Y-intercept. And again, there's two ways to do it, Brian. We can either kind of go backwards. Well, we know each kid costs $5. So 4 kids would cost 95, 3 kids would cost 90, 2 kids would cost 85, 1 kid would cost 80. So therefore 0 kids would cost 75. So the Y-intercept is indeed 75. So this is one way to do it. We kind of just go backwards and think, well, what is it at x equals 0? Okay. There's another way that we can solve for the y-intercept. And Sophia probably has done questions similar to this in school already. But we have the equation y equals mx plus b. Right now, we solve for the slope for this one. The slope is equal to 5, right? We know the slope is 5. So right now, our equation looks like this. Y equals to 5x plus b. We want to solve for b because we don't know what the intercept is. But we have x and y coordinates. We have these two coordinates, right? These two are coordinates on our graph. When x is equal to 5, y equals 100. When x is equal to 12, y equals 135. We know these points hold true on the graph. So we can actually just substitute these points in. So I'm going to choose the first one. It doesn't matter. You could choose the second one if you want. I just like the 100 and the 5 because I think it's an easier number. So we have 100 equals to 5 times 5 plus b. 100 equals to 25 plus b. Therefore, b must equal to 75. Does that answer your question, Brian? So again, you can either think about it logically by going backwards to figure out what happens when there's 0 children and how much is the total cost, or we can do it the better way, which is this way. And that is, we need to think about the equation of the line, which is y equals mx plus b. This time we don't have the b. We don't know what the y-intercept is. So we can calculate it by putting in the x and y coordinates respectively. Okay, it doesn't matter which point you choose. You could choose this point as well. You could say 135 is equal to 5 times 12 plus b. 135 is equal to 60 plus b. You'll still work out that b is equal to 75. So it doesn't matter because these coordinates hold true on all of this point. These points all hold true on this line, right? So we know that regardless of which point you choose to plug in, it's always going to work, okay? So that's how Lydia managed to solve for the y-intercept as 75. So she was very clever in doing this. Very good job. Are you sure you're not in grade 9, Lydia? Yeah? Are you doing grade 9 math at school? Just grade 8? Oh, very strong. Very good. And again, this is just very long-winded explanation of what we just did, but the slope is delta y over delta x, which is y2 minus y1, and so on and so forth, okay? And then they get the two different equations of a line, and then we can figure out which one costs less, okay? So again, we're going to recap this a little bit. So we have this y equals to 15x, and this one, if I recall, is y equals to 5x plus 75, right? If I change the question around and I asked you guys, who can tell me what the break-even point is? Like, right now we have two different rentals, right? There's probably a certain number of kids that we can that would basically cost the same for both. So for example, if there's only one kid that's going to attend your party, it's obviously cheaper to go to the community center, right? If there's only one kid, it's only going to cost you $15. But if you go to the school gym, if you have one kid, it's going to cost you $80. So that's not a very good buy, right? So at what point does it become break even? And then we can kind of see from at what point we should start going to the school gym for the rental instead of the community center rental. Can anybody tell me at what's the break even point? I've given you the two equations over here just as a recap. But how many kids approximately is the break even point? How will we know when we should go with the community center rental and when we should go with the school gym rental? And then afterwards, we'll illustrate it graphically so that people can see it. Yeah, Lydia.
I think it's about 7.5.
Yeah, it is. Good job. And hopefully you solved it algebraically by doing 15x must equal to 5x plus 75. So therefore, 10x must equal to 75. X is therefore equal to 7.5. So again, for this purposes of this question, 7.5 kind of doesn't make sense because we can't really have 7.5 kids. But we might be able to say something like, if we have 7 kids or less, then we should probably go with this option. And then if we have 7 kids or more, we should go with this option. And then we have 8 kids or more, we could go with this option. So again, if we have 7 kids, we should go to the community center rental because it's going to be cheaper than going to the school. And then once you have 8 kids and more, you should start going to the school gym rental. Okay. And again, you could calculate it in the equation if you want. 15 times 7 is equal to 105, right? And this one times 7 would give you 110. So that means this one's a little bit cheaper by $5. Okay. And once you have 8 kids, this one goes to 120, and then this one would only be 115. So school gym would be a little bit cheaper. So again, the break-even point is exactly 7.5 kids. So we would know that for 7 kids or less, you should go to the community center. For 8 kids or more, you should start going to the school gym. Okay. And this is kind of how we can calculate to see how we can save some money, right? Now let's see if we can illustrate this graphically so that people can read it nice and easy, so to speak. Okay, so really good job, Lydia. Hopefully you did solve it algebraically instead of listing out the numbers and see what point they cost more. But I suspect that most of you are capable of drawing the graphs. Actually, no, I don't think they taught how to draw graphs yet for my other grade 9s. Sophia, have you learned how to draw graphs with the equation yet? Or do you still just do it with table of values in school? I think you're still just doing it with table of values, right? You haven't learned how to draw the graph just by looking at the slope and the y-intercept.
Yeah, we didn't really do the line equations. We did slope, but
you did slope?
no.
Okay. So again, this might be a little bit further on than what you've learned in school. But the fact that you already know the slope is a really good thing, okay? Maybe a little. That's okay. Jerry, you're in grade 6. The fact that you can even understand this is very important, impressive in my opinion already, okay? That means your math fundamentals must be very, very strong, Jerry. So I'm very impressed. So again, the easiest way for us to graph anything is to create a table of values. That's what you're used to doing from school, right? Like back in the elementary school, you would always create a table of values. So we could do it as well here. So we could have an X and a Y column. And then you can say when X is equal to 1, Y is equal to 15. When X is equal to 2, Y is equal to 30, and so on and so forth. That's for this one, right? And then we could create an X and Y column for this one too. We could have an X and a Y. When X is 0, Y is 75. When X is 1, Y is 80. When X is 2, Y is 85, and so on and so forth. Okay. To plot any line, we usually just require 2 points. You don't need more than 2 points to draw any line, right? You need 2 points, and then afterwards we can play connect the dots. So again, it's not done on graph paper, so you guys will have to forgive me if it doesn't look perfectly straight, okay? But right now we're just gonna have 1, 2, 3, 4, 5, something like this, okay? Sorry about that. And then what happens is for this one, we'll make the scale go up by, I don't know, 10. 10 is reasonable, right? 20, 30, 40. Sorry, guys, it's really hard for me to write with the mouse. So some of these numbers look a little jumbled up, okay? 60, 70, 80, 90, and 100. And it's good enough, okay? My hand's getting sore. So let's graph the first one. I'll graph the first one in blue. 1 and 15. So the first one has a point at 1 and 15. And actually it goes through 0, 0, 2. When X is 0, Y is 0. So I'm actually going to use the point 0, 0 because it's just easier than doing 2. You could do 2 and 30 if you want to. 2 and 30. Doesn't matter. And you could keep plotting it if you want to. You don't need 2 points though. If you're plotting more than 2, kind of means you're wasting your time. Okay, you only need 2 points to make a line. So this is going to be representative of Y equals to 15x, right? Now we plot this one, y equals to 5x plus 75. So let's plot that one in green. Okay, y equals to 5x plus 75. Well, I know at 0, it's going to be 0 and 75, so that's 1 point. And then we have 1 and 80, so that's over here. And then again, you can plot another one if you want. You could have 2 and 85 if you really desire it. But again, it's not necessary. It's a straight line, so technically you just need 2 points. Play connect the dots. Okay. So we connect it. And if this was done on graph paper, in a perfect world, they would intersect exactly at 7.5. Okay. It's not a perfect world because I didn't draw this chart very nicely. But in a perfect world, this should be 7.5 for the x coordinate. Okay, that should be where they intersect. So you would be able to see graphically that this blue line costs less than, because it's underneath the green line, right? This blue line costs less all the way up until 7.5 compared to the green line. And then after 7.5, the green line starts costing less than the blue line. Okay, so that's basically how we would represent it graphically. This point of intersection represents the point at which they break even. And then you could show your consumers which one costs more based off of this graph. You'll also notice that this one has a y-intercept of 0 because it's 15x, right? There is no y-intercept. It's technically 15x plus 0. So it goes through 0, 0. Whereas this one goes through 7.5. So not 7.75. Okay, so the y-intercept is 75. You'll also notice that the one that says y equals 15x is steeper than the one that says y equals 5x. And that's because 15 is a bigger number than 5, right? So that means this line is going to be more steep than this line. So the slope itself tells us a lot about the line as well. It tells us approximately how steep this line is going to be. Okay? The steeper the slope, the larger the number. Okay. So that's how we would illustrate this problem graphically. And again, you can even introduce a third place if you wanted to. You could introduce a third place that says, oh, you know, you can hold your party at Michael's house. Okay, it's just a flat fee of $300. Okay, so when should you hold your party at my house? When should you hold your party at Michael's house? Well, again, a flat fee of $300 is very easy. You just go to 300, and it would just be a straight horizontal line across, right? Because no matter how many kids there are, it costs $300. So eventually, there's going to be a point where it's cheaper to throw the party at my house, right? Like if you have 100 kids attending a party, for example, let's just all go to Michael's house because he only charges a flat fee of $300. So again, we can compare to see which one is going to be more worth it graphically as well. So once you're in grade 9, they'll ask you to be able to solve the equations graphically as well as through algebra. Usually algebra is more important because most of your questions on a test is going to be asking you to be able to solve these questions and isolating for the variables algebraically. Okay, graph is kind of more like a project that they might ask you to do. Usually they'll have a culminating project that you have to do at the grade 9 level, and they might ask you to solve for something graphically that way. Okay. Generally speaking, if you know the algebra, it's more important, in my opinion, at least. Okay, so we already covered this for the electric scooter. Everyone seems to understand this fairly well, so I don't have too much problems. So let's try one more question and see if people can tell me the answer. Let's try this question. It says information is provided regarding the fee structure for 2 different painting companies. Each company's fee structure is linear. What's the difference in cost between the 2 companies if 14 hours of work is needed? And again, you can either illustrate this graphically or you could do it by algebra. Algebra is probably better. And again, you could also figure out the break-even point if you needed to, but the question doesn't ask for that. So this question, they made it very easy. All you have to do is figure out how much it costs company 1 for 14 hours worth of work and how much it costs at company 2 for 14 hours worth of work. So this one's very easy. So what is that? 120 divided by 3, that's 40. So y equals 40, x plus b, 312 equals 3 times 4 plus b, 312 equals to 160 plus b equals to, what do you got? 152. Okay, so y equals to 40x plus 152. And this one's nice and easy. This one, it's not cutting through any of the lines nicely. But either way, it goes through 0, 0. So that's pretty easy. So that is a, wait, does that go through 0, 0? 75. That's 55, right? 55, yeah. Okay. So this one is just y equals to 55x. Hopefully, all of you have the equation of the line for both of these companies. So for company 1, I worked it out to y equals to 40x plus 152. Hopefully, I didn't make any calculation mistakes. It's been known to happen. But hopefully, you guys can confirm that this is the equation of the line. And for company of the 2, the equation of the line I worked out to be y equals to 55x. And now all we have to do is sub in 14 for x, because it represents the number of hours worked. And then we could calculate the cost, and we could see which one is cheaper. Okay. 14 hours. So again, we could plug it in. 40 times 14 plus 152. 40 times 14, what is that? 0, 0. 560 plus 152, 712, right? And for this one, it's 55 times, what was the number? 14, 2, 2, 2, 5, 5, 770. Okay, so I'm working it out to company 1 is cheaper, and it's cheaper by, what is that, $58. Okay, so hopefully all of you got the same answer. That company 2 works out to be $770 for 14 hours worth of work. Company 1 works out to be $712 for 14 hours worth of work. Therefore, company 1 is cheaper by $58. Did everyone get the same answer? Sophia, you got it? Yeah? Okay. Last question. Well, it's not so much question, but we'll since we're on the topic for equation of a line, I guess this would be more of a review for our students who are doing grade 9, so mainly Sophia. Sophia, do you remember what the equation of a line would be for a horizontal line? This is where my grade 9s left off, I think. They learned about the equation of a line for horizontal lines and vertical lines. Have you learned this in school yet? Not yet? No? Okay. So right now, you guys have learned the equation y equals mx plus b. This applies to most lines. Okay, like 99% of lines, because most lines are diagonal, right? Most lines look something like this. They're some kind of diagonal, okay? What happens if we have a line that is perfectly horizontal? What's the equation of this line? Can anybody tell me? What's the equation of my line? If, let's say this is 5, okay? X equals something very close. Jerry, not quite. Horizontal, not vertical. Very clever, though. Very clever. Y equals something very smart. So in this case, because it passes through 5, what will my answer be then, Jerry? Y equals to 5, right? It's obvious because look, if you look on this line, this is when the x is 1, y is 5. When x is 2, y is 5. When x is 3, y is still 5. So the equation of this line is just y equals 5. The unit y is 5, regardless of what the x coordinate is. Okay. So whenever we have a horizontal line, you can think of it kind of like y. Horizontal line, whenever you have a horizontal line, the equation is always y equals to a number. Okay, your textbooks will probably just write a y equals k. Something like this. Now, who can tell me the slope of this line then? let's start easy. What's the y-intercept of this line? Who can tell me what the y-intercept is of this line? Of the line y equals 5. What's my y-intercept? Does anybody know? Y equals 5. What's my y-intercept? It's not 0. It's not 0. Be careful. Oof. Yeah, Lydia?
5?
Yeah, it's 5. It's where it crosses the y-axis, right? It's literally drawn right here. So when we say the y-intercept, I like to write it as a coordinate. So I would say the y-intercept is 0 and 5. Okay, y-intercept 0, 5. I've seen textbooks and some teachers as teach it just y-intercept is equal to 5. So I guess it's acceptable. But I don't like writing it that way. I recommend that when you guys quote the y-intercept to quote the actual coordinates, okay? If you quote the coordinates, you'll never be wrong. If you write y-intercept equals 5, if I was the teacher, I would ask you, well, is that x equals to 5 or y equals to 5? I don't understand what 5 is, because 5 is not a coordinate, right? So I recommend 0, 5, okay? Who can tell me the slope then? I think this is what Jerry was trying to say earlier. Yeah, Lydia, what's the slope?
0.
0, very smart. Wow, you guys are good. Because we can almost think of this as y equals to 0x plus b, right? So the slope is 0. That's why it's y equals to 5. Okay, very clever. The slope for any horizontal line, oh, by the way, when you draw horizontal lines, make sure they have an arrow at the end to show that it denotes that it goes on forever, okay? Otherwise, it becomes a line segment. So don't draw it the way I did. Draw these arrows, okay? So when we say y, what was I on? Oh yeah, when we have any horizontal line, the slope is always 0. Okay, you don't have to think about it. The slope is always 0 and it's always y equals to a number. You guys probably already know what my next question is going to be, but who can tell me the equation of a line for a vertical line then? If I have a vertical line, and let's say this goes through 5, what's my equation for this line? Lydia?
X equals to 5.
Oh, very clever. So you probably already noticed the pattern where you have a vertical line, the formula is x equals to a number. In this case, x equals to 5. So now I'm going to ask you the same 2 questions I asked previously. What's my y-intercept for this one? What's my y-intercept for this vertical line? Yep, Lydia?
0.
No. Y-intercept doesn't go through 0.
Oh.
What's my y-intercept? So the answer is it does not exist, right? We don't cross the y-axis. This is parallel, right? This is going up, down. It's never going to cross the y-intercept. So you can't say 0. That might have been what you meant in the sense that it doesn't go through 1. But if you say 0, technically in math, it means you're telling me it goes through the point 0, 0. And that's not true, okay? So the answer is actually does not exist, okay? It does not cross a y-intercept. There is no y-intercept. Does that make sense? So there's a difference between 0 and does not exist in math. We have to use the right term, otherwise it's technically wrong, okay? And what is my slope for this one then? Who can tell me the slope for this line? What's my slope? You told me the slope for the horizontal line was 0. What's my slope for the vertical line? Sophia? Yeah.
There is no slope.
Good job. It does not exist. Very smart. So for a vertical line, we cannot have a slope. And we can prove this, right? Who can tell me how we can prove this? Suppose I tell you that this coordinate is 5 and 3, and this one is 5 and 4. Okay. It's not a function. That's true. It is not a function. Very smart, Jerry. But just because something is not a function doesn't necessarily mean that it has no slope. Well, I guess it kind of does, because for the other ones, it wouldn't be a linear line. But you can calculate the slope for the other ones at a point, though, right? So you can still calculate the tangent line for the slope. But for this particular question, I wouldn't necessarily use it's not a function as the answer. You're technically right. It isn't a function. But what would be a mathematical way that we can prove that there is no slope for this particular question. Does anybody? Yeah, Sophia.
It's 0 over a number, and that's not.
0 over a number is 0. That's acceptable. So it's not 0 over a number. It's go backwards. Say it backwards. You got it. Remember, the slope is equal to delta y over delta x. So therefore, it's equal to a number over 0, right? That's right. This is 4 over 3. Take away 5 over 5 minus 5. So that's 1 over 0. Can we ever write 1 over 0? No, right? It's undefined. Very smart, Jeff. So therefore, the slope is undefined for any vertical line. Does that make sense? Outside of these two circumstances, outside of the horizontal line and outside of the vertical line, every other equation where you have y equals to 3x plus 2 or 2x plus 3y plus 7 equals 0, you can write this any way you want. It doesn't matter. You can write negative 3x plus 7x equals to 14. They're all going to be some kind of slanted line, like a diagonal line. Okay, maybe it won't be super diagonal. Maybe it could almost look like it's horizontal, but it won't be perfectly horizontal. Okay, so that is basically how we illustrate equations graphically. Okay, anything where you have the x to the power 1 and y is to the power 1, it's always a straight line. It's just, and it's usually going to be a diagonal. Like 99% of the time, it's going to be some kind of diagonal line. You'll know when it's a horizontal line, when it's y equals to a number. And obviously vertical lines is just x equals to a certain number, okay? Everything else that has some kind of combination of 1x and 1y is going to be a diagonal line, okay? So I'm very impressed with everyone. Everyone seems to be very strong in this subject, even for the students who hasn't started learning grade 9 math. Actually, there are infinite types of lines, so it's kind of infinite. Yeah, there's definitely infinity types of like diagonal lines. You can have as many different types of lines as there are for the as there are numbers. So you're definitely right about that. We're never going to be able to draw out every single line, right? So everyone's very strong. I was very impressed by everyone. Everyone seems to understand this topic perfectly. So I suspect that all of you are going to get 100% on this topic when you guys get there in grade 9. I'm almost certain of it. It's really good work. That's it for today. Enjoy the rest of your winter holidays. I believe most of you will have 1 week left of break. So hopefully you guys can enjoy your time off from that, okay?
Good timing.